A two-dimensional array is designed to hold contents of a table with entries of the same data type, where the numbers change across two or multiple dimensions. Instead of a single upper bound or size, there are two to be mindful of. M for a table with m plus 1 rows, as this shows over here, and n, the upper bound, column upper bound, for m plus 1 columns. Again, remember, the indices go from 0, 1 all the way through m for a table with m plus 1 rows, and the same thing with n from 0, 1 all the way through n for a table with n plus 1 columns. So, a two-dimensional array, dim mthpmt 4,5 is double, holds 5 times 6, 0, 1 through 34, which is 5 rows, 0, 1 through 3, 4, 5, which is 6 columns, or 30 monthly payments altogether. Each row, each of the 5 rows, represents different borrowing amounts, right, 200 all the way to 400 in increments of 50,000, and each of the 6 columns represent different interest rates from 5 to 7.5 in increments of 0.5%. So, for example, MTH payment 3,4 at the intersection of row 4 and column 5 is a payment on a 30-year $350,000 mortgage at 7% interest rate, and it happens to be $2,328.56. So just like a simple one-dimensional array, two-dimensional array can also be implicitly sized by listing all of its elements in a row-by-row format. The values in each row are enclosed in the inner set of open and closed braces. So this is the first row with 1, 2, 3, 4, 5 columns, which are then strung along with the remaining rows, okay, as many rows as there are in the whole data set. The whole thing is then closed or enclosed in open and closed set of outer braces. Okay, you will not tend to do this, manual like this all that much. The data is mostly going to come from a text file, because it will be hard to hard code it like this. Okay, so the array name, as you'll notice right here, is followed by an open closed set of parentheses, but in addition there's a comma in between indicating the two-dimensionality. Okay, redimensioning works the same way as it did with one-dimensional arrays, but you need to be careful when using the preserve keywords. It's only the second dimension getting resized in that case. The get upper bound of 0 and get upper bound of 1 return the rows and columns upper bounds of m and n in our previous notation. You could use this for the one-dimensional arrays as well, but we'll continue to use the count method instead. Okay, we will demonstrate reading from a text file into a two-dimensional array, which is very similar to reading into an array of structures shortly. If you think about it, an array of structures is a one-dimensional array where the array size determines the number of rows. Number of columns is determined by the number of data structure members. So our 2D array is a special case of an array of structures where each structure member represents the same characteristics as is of the same data type. Okay, we will demonstrate this, as I said, with payment calculator example shortly. Okay, so what we'll do, we'll switch to the FRM payment calc 2 dim form, the third one in our payment calculator project, and you'll notice when you do that, right click View Designer, that it's very similar to the one we had in a previous video. The general idea is that we want to load a grid with monthly payments for different amounts and interest rates on a conventional 30-year mortgage. When the user enters, and this is going to be entered into this, or displayed rather, into this grid. When the user enters in this text box a maximum affordable payment, the loans he or she can afford in this grid will be colored green, the unaffordable ones will be colored red. Okay, so we want to use a 2D array, two-dimensional array, to store the calculated monthly payments for a range of borrowing amounts and interest rates, as was shown on the previous slide, previous couple of slides ago over here, right? So that's the range of amounts borrowed and the interest rates. Okay. Okay, and then we're going to display, obviously, as I just said, into this grid when the form loads. Okay, so what we'll do, let's go step by step through this. We'll begin by switching to the code, okay, and at the top we will declare a MTH PMT two-dimensional arrays with 4 for the row upper bound and 5 for the column upper bound as double. So it's available in both the form load and the click event of the show button, right? So this will hold again 5 rows worth of amounts borrowed from 200,000 to 400,000 in increments of 50 grand, and this will store 6 of the interest rates from 5 to 7.5% in increments of 0.5%. Okay, then what we'll do, we'll go into the load event and we'll declare some variables starting with amount as double, and we'll initialize it at 200,000, which is the lower bound for the amounts borrowed, and dim rate is going to be just declared as double, and we'll initialize it later on. Dim payment as double will be the monthly payment for each combination of the amount and interest rate, as you'll see shortly. Okay, then what we'll do, we'll size the grid by defining both number of columns and rows. Okay, so unlike the previous examples where we only define number of columns, like 3 for that previous video with what is it, last name, amount, and monthly payment, and we did not know the number of rows in advance, so we sort of added them one by one. Here we know the number of rows. It's going to be essentially 5, right? 4 plus 1, and we know number of columns is going to be essentially 6, or 5 plus 1, which we can get using that get upper bounds of 0 and get upper bounds of 1. So we will not need to use that rows property and add method and so forth. So let me demonstrate, right? So first of all, we'll set the DGV loans, the row count, right, which we haven't done before, using the array upper bound of 0, which is for rows, and we'll add 1 to get 5 from 4, right? And we'll do the same for the column count. Okay, and we'll do upper bound of 1, which is the upper bound for the columns, which is this 5 over here, and add 1 to get 6. So now we have ourselves a 5 times 6 equals 30 monthly payments, two-dimensional array, or grid in this case, I should say. Okay, we will also throw a little bit of code. DGV loans dot, I found this sort of obscure row headers width by googling around, and we're going to set that to 100. The default is some small number that's not going to allow us to fit those amounts borrowed, as you'll see later on. Okay, then we're going to do the nested loop for I as integer, going from 0 to DGV loans dot row count minus 1, and then we'll specify DGV loans dot rows of I, right? So for the ith row, the header cell, again after a little bit of googling, the value specifies what goes into the header of a row. So it's not the same as it is for the column. Let me use the name property to define the headers of the column. So probably the header cell property is available for that one as well. But anyway, we're going to take the amount, which is going to be 200,000, and then we're going to convert it to string, and we're going to format it as currency without decimals because it's a large number. So it's going to be 200,000, 250,000, 300,000, and so forth. The rate is going to be reinitialized to start with 5% for every row, and then we're going to loop through columns from J as integer, going from 0 to DGV loans dot column count minus 1, and here we're going to calculate the payment, but only if okay, we're going to calculate the payment here using the financial library, and then PMT function rate divided by 12 to get monthly. We got 300. Oh, that's a number of payments. Oh yeah, these are mortgages, right? Yeah, these are all mortgages. So 360 right? There's no car loans or weird other types. So it's 360, which is 30 years times 12. And then we got ourselves a negative amount to get a positive payment. Okay, and then we're going to display that payment, DGV, the rows in the ith row and cells J, right? So this is, the intersect of row I and column J. We need again value like before, and we're going to convert the payments to string as currency with 2 decimals. Then we have to increment the rate by 0.5%, which is 0.005, and go next, and then go next, and then here we need to increase the amount by 50,000, right? 1, 2, 3. Okay, so the only other thing we need to do, but only once, if I is 0, we could have done it for any I, we need to set we could have done outside of these 2 loops in a separate loop, whatever. We're going to set up the columns header by setting up the name property to rate that's also converted to string with p percentage formatting, right? Okay, so again, this sets up the bounds for the column, so it's going to be 5 times 6. All right, we're going to loop through all rows from 0 to 5, from 0 to 4, I'm sorry, and then from all the columns from 0 to 5. We're going to set up the headers, 200,000, 250,000, and so forth. We'll start, every inner loop with a rate of 5%. We're going to display those rates into the header, but only once for the first pass through for the first row of the grid. We don't have to obviously repeat the same thing 5 times. Then we'll calculate the payment, display the payment converted to string as currency, increase the rate by 0.5% to 5.5, 6, and so forth, and then increase the amounts. This should work unless there's a mistake somewhere. This should work, and it should load. It should load. This is the old one. Hang on. So we need to make sure that the project properties is set to the toDim. Save, and this should load unless there's something wrong. Yep. Okay, 200,000 to 400,000, 5% to 75%. These are all. What was that? 7%, 2,328. I believe that matches what we had in the presentation. 2,328.56. Yep. Okay, so we're going to stop here, go back, and then program the show button. So the show button is relatively simple. Okay, we need 2 variables: max PMT. We'll assume 2,000 is a good number, and then current PMT. Both double the current PMTs, whatever is the current cell as we loop through the entire grid. Okay, so we're going to grab that max PMT C double from that txt max PMT.text. Again, for I as integer, going from 0 to dgv loans.row count -1, and then for j is as integer, going from 0 to dgv loans.column count -1. Okay, so what we need to do, we need to make a test. We need to test whether, okay, first of all, we have to assign the current payment, right? Current PMT is the C double. Remember now the grid contains strings. DGV loans dot rows I dot cells of j dot value. Right? So we take those grid elements, convert them to double, okay, and then we compare. If this is under the max payment, then we want to color the cells green, else we want to color them as red. So so now again, after a little bit of googling, rows of I, cells of j, okay, dot, apparently style property has back color property, which is then set to color dot. I'm going to use a light green versus the regular green, and then I'm going to copy that and paste it, and I'm going to change the color to light coral instead of red, so it looks a little better, otherwise it's the same. Okay, and then we go through all 30 of them like that, and they're going to split into two camps, you know, provided we enter a reasonable okay, if you enter a reasonable payment like 2,000, right, you see somewhere in 1,000 range, somewhere in 2,000 range, that should then split into the green affordable and red unaffordable portion easily, so you can see that. So we're going to close it, switch back to the presentation. Okay, and okay, make sure we've done all this, we've done all that, and then we're just going to go through the summary. So this concludes our video series on arrays and structures, both of whom represent the fundamental shift into complex data types for us. They represent the types of data contained in spreadsheets and databases, which is to say real business data, and they're frequently used as such in all kinds of analysis. So after we complete additional, we're going to have several in-class projects and examples. You'll be then ready to start on the second assignment for this class.